How would you feel if your level of energy depended on your friend's actions? If he runs, you feel tired, and if he eats, you're energized. Your drive to do things is completely out of your control. This, of course, is not a realistic situation. But when we move to the electric world, we find components that exhibit exactly this behavior. Dependent sources are electric sources whose voltage or current depends on the voltage or current somewhere else in the circuit. In other words, their ability to convert non-electric energy into electricity is dependent on the ability of some other component in the network. This concept may sound a bit strange because the most popular electric source that we interact with on a daily basis is the battery, and batteries are independent sources. But it's thanks to dependent sources that all the electronics in your house work correctly. Inside all of your cool gadgets, such as your laptop and smartphone, you can find millions and millions of transistors. Even though we're not ready yet to look at transistors, we will get a sneak peek at their behavior by analyzing dependent sources. There are 4 types of dependent sources. If you understand fully how one works, then you'll know how all of them work, so let's start with the basic. The name of the source tells you 2 things: the type of source, either voltage or current, and the controller parameter, either a voltage or a current elsewhere in the circuit. For instance, a dependent current-controlled voltage source is the name for a voltage source that is controlled by a current in a different part of the circuit. Following this logic, a dependent voltage-controlled voltage source is, as you may guess, a voltage source that is controlled by a voltage in a different part of the circuit. By now you're probably a bit dizzy by the number of times that we have said the words voltage and current in the last minute, so let's look at an example to help us clarify the main concept. Suppose we have a 1.5 volt battery connected to a 0.5 ohm resistor and to a dependent voltage source that is controlled by the current IB flowing through the resistor R1. By the way, just like the symbol for an independent source is a circle, we use a diamond for dependent sources. The value of the source is typically a constant multiplied by a voltage or a current. In this case, the constant is half and the current is IB, which is flowing through the 0.5 ohm resistor. In order to know the voltage generated by the dependent source, let's call it VD, we need to first find the current IB. Let's break down the problem following our recipe. We know the resistance R1 and the voltage of the battery. We need to find IB flowing through the resistor. The relevant equation here is Ohm's law. We have that V1 equals IB times R1. Solving for IB, we find that the current is the voltage V1 divided by the resistance R1, or 1.5 volts divided by 0.5 ohms. Then the current IB is 3 amps. Now that we know IB, we can easily find that the voltage of the dependent source is 3 amps divided by 2, or 1.5 volts. That's it. Now you know how to work with dependent sources. There are 4 types of dependent sources: dependent current-controlled voltage source, dependent voltage-controlled voltage source, dependent current-controlled current source, dependent voltage-controlled current source. Let's look at another example. We connect a 5-volt battery to a 2-ohm resistor, and we also have a dependent voltage-controlled current source connected to a 5-ohm resistor as shown here. What is the value of alpha so that the voltage across R2 is 10 volts? We know the voltages V1 and V2 and the 2 resistances R1 and R2. We need to find alpha. The relevant equation is again Ohm's law. We need to know the value of Vx. Since the resistor R1 is connected directly to the 5-volt battery in nodes A and B, we can see that the voltage Vx is equal to VAB, or 5 volts. Now we can say that the value of the dependent current source is alpha times 5 volts. The problem is giving us the voltage across the resistor R2 to be 10 volts. We can apply Ohm's law to find the current flowing through R2. We have V2 equals the current I2 times 5 ohms. Solving for I2, we get 10 volts divided by 5 ohms, or 2 amps. Since the dependent source is in series with the resistor R2, the current alpha Vx is the same as the current I2 flowing through the resistor. Thus, we have 2 amps equals alpha times 5. Solving for alpha, we get 0.4. What is the unit of alpha? Since this is a current source, the final unit must be amps. Vx is in volts, so alpha must be amps divided by volts.